we define the new terms today is called Kroneker delta, and it has vast applications in tensor calculus. At first, let us introduce what Kroneker delta is. Now, by the definitions. So, definition of Kroneker delta is delta ij. We are writing I here for the superscript variable and j for the subscript variable as 1 when I equals to j and 0 when I is not equals to j. So it should be noted that if I equals to j, then we get it is 1, and also we know if it should be notable that I equals to j when it's happened, then del xi del x j, that will be 1. If I is not equals to j, then since xi and xj both belongs to same coordinate, so they are independent. And we can say hence del xi del xj equals to 0. Thus we can say also del xi del xj is equal to 1 for I equals to j and 0 for I not equals to j. So we can write it delta ij, that will be equals to del xi and del xj. Now we see in the earlier situations when the coordinates of xi are the functions of when the coordinate of xi are functions of coordinate of x bar j, and which are the functions of the coordinates of the coordinates xk, then del xi del xj is equal to del xi del xk equals to del xi del x bar j del x bar j del xk. Therefore we can write it as delta ik is equal to del xi del x bar j del x bar j del xk in this way. So here we have already done, and how to use the Kroneker delta we have some sort of idea in tensor calculus. Now let us introduce how we can write the summation conventions in tensor calculus. That's a very important part. At first, we know the expressions as ax to ay1, suppose ay2 dot up to an, a1 y1, a2 y2 up to an yn, using the notations sum of j equals to 1 to up to n aj yj in this way. And if we are already omitting this variable, sometimes we write it as aj yj, that means this. Now we should use all these summation conventions and how to write. Let's see. Suppose if we write it here, b1 c1 b2 c2 or dot up to bn cn. How to write this convention? Simply that will be written as j equals to 1 to up to n bj cj in this way. By convention, or simply it will be written as bj cj. So it's clear. Now for the next part is, if we write it delta I1 C1 delta I2 C2 up to delta IN Cn, that will be simply written as, for k is equal to 1 to up to n delta ik ak, or simply ck, or simply it will be written as delta ik ck. Similarly, if we expand some of the expressions, but here we use the summation notation and summation convention of the expansion. Now if we are writing reverse of it, that means expansion of the following summation conventions. If we consider it here as aij bjk, if we write here for j is equal to 1 to up to n aij bjk, what happens there? If we observe it, j is the common terms, so already we have noticed that this change will be on j. That's why these things happen. That's why we write it here j equals to 1 to up to n, and it's clear. So what will be it? I1 bi1k plus a I2 b2k. In this way we expand ain for I equals to 1 to up, j equals to 1 to up to n bnk. Now if we consider another example, aim ym, what will happen here? Already we use the summation convention over m, so m is equal to 1 to up to n aim ym, that will be ai1 y1 plus a I2 superscript variable I subscript to y2 in this way up to a im yn. So far we have already done the few examples. Now one more example to be considered. Del x yj root over g bj in this way. If we write it here, so here also taking the summation convention over j, it is clear. So j runs from 1 to up to n del of yj root over g bj. So it will be del y1 root over g by1 plus del of y2 root over g b2 etc. In this way we can say del yn root over g ybn. So already we know the following summation conventions. Now if we evaluate some of the examples about Kroneker delta. For the evaluations of Kroneker delta, delta IL, delta LJ and delta IJ. Now at first if we evaluate, what will be happening here? What will be the quantity? So actually delta IL, it is clear, del xi del xl clear, and delta Lj is equal to del xl del xj and delta ij equals to del xi del xj. Now if we substitute the value, del xi del il del lj and del ji is equal to delta xi, here it is l, del xl delta xl del xj and delta xj del xi. So what will be its value? Suddenly we follow by the chain rule. We have del xi and del xi, that will be delta of ii. Now we find it, what will be the value of delta ii? Delta ii is equal to delta 1 delta 2 up to delta nn. So all will be 1 plus 1 up to nth term, so the result will be n. Therefore we can say delta il, delta lj and delta gi is equal to n. This will be the final answer. Now, a very important aspect, one problem is very important for the use of Kroneker delta. Problem is delta ij aj. What will be its value? So it is very obvious and clear, the taking the summation conventions over j. So it will be j equals to 1 to n, j runs from delta ij aj. So it will be clear. If we taking it and actually if we observe it, what will happen there? Taking the summation convention at first, if we observe it, if we take I1, 1, 2, 2, this is summation conventions, and already it is obvious every value will be 0. every value of the term will be 0. Already one term exists. Which one is this? When j equals to k, that is when j equals to I, we have delta I aj is equal to aj is equal to when j equals to I ai. This will be 1, and all other terms except j equals to I is 0 if we consider, because it's Kroneker delta, and if we plot all other terms, every term will be 0 except for the term j equals to I. Every term will be 0. If we expand this term like I1, this is j not equals to I. If we take j any arbitrary value, whatever may be the I is, that first we are finding j equals to I, that will be 1. So it will be only ai. All other term will be 0. If we consider this. Similarly, we can say delta ij delta kl ajl. Already see jl over jl. So when here also when j is equal to I and l is equal to k, we have delta ii delta kk, and it will be aik. So the result will be aik. Now we have get some of the idea how to use the Kroneker delta and summation conventions, and we are already familiar with this type of systems in tensor calculus. Thank you.